Well, this is the potentiostat. The potentiostat, it has 3 cables that connects to 3 electrodes respectively. These cables, they are labeled. The green one, the green alligator, it goes to this working electrode. The red one goes to the counter electrode, and the white one goes to the reference electrode. Just recall what we learned from our physical or analytical chemistry course. The reason we want to have 3 electrodes is because we want to avoid the polarization of the electrode during an electrochemical process. Okay, so the concentration change, it's going to cause this polarization, and then applied potential is not the desired potential anymore. So to compensate that one, we have a 3 electrode system by implementing a reference electrode in the entire cell. So this potentiostat, it has 3 of cables correspond to 3 electrodes in total. So when you're doing this ensemble experiment, of course, you will also need to have a total of 3 electrodes that can connect to the 3 cables. Usually the reference electrode we use is going to be a silver chloride electrode. The counter electrode, typically it is a piece of platinum foil or a platinum wire. And then lastly, the working electrode is either a round disc solid electrode or an ITO slide for the single molecule experiment. Acta is bringing in an electrochemical cell here. This cell contains the phosphate buffer, which acts as an electrolyte. Okay. It is conducting. The one he's taking out now, this is a glassy carbon electrode. This will act as the working electrode. It's inserting the working electrode into one of the holes on this stopper. Now he's taking out the reference electrode. Reference electrode should be stored in 1 mole of the potassium chloride solution. When it is not in use, it should always be placed back to the same centrifugal tube. And the last one he's taking out is a platinum wire counter electrode. Okay, so all 3 electrodes need to be submerged in the electrolyte solution. Check and make sure there's no air bubbles at the bottom of the electrodes. Otherwise, there won't be any of the electric contact. And then clamp those alligators to the corresponding electrode will make the electric contact. Now the preparation work is practically done. The last step is to connect the USB cable to the computer. Okay. And in order to run electrochemistry, we would click the CHI 1200C, this icon. That will open up the software that controls the potentiostat. The first thing we need to do is to select the technique. This is under setup and then technique. We have the cyclic photometry, which is the very first one, or we could also choose the chronoamperometry if that one is needed. Okay. Let's just select any one. We can start from the cyclic photometry, and once this is set, we'll go to the parameters page, and then from here we'll set the parameters for the cyclic photometry. The very first entry is initial potential. This is the starting potential we set at the beginning of the experiment. Let's just assume we're going to be scanning this potential between plus 0.3 and minus 0.5 volt. Let's just set it to 0.3. Usually the high voltage is going to be identical as the initial voltage. and then the lower voltage is going to be the other end of the entire scanning range. The scanning rate is how fast it will do the scan. Default is 0.1 volt per second. You can change the scan rate as needed or correspond to the literature. The sweep segment is how many of the cycles you would like to have. To complete one cycle, of course, you will need to have two segments, one of a forward scan, and then another one is going to be the backward scan. A forward and a backward scan will complete a scan cycle. If you want to have, say, 10 cycles, then you will set the sweep segments to 20. And the sample interval is how many of the data points you would like to have for each of the scan. Usually we do not change this number, we just leave it as is. The quiet time is when you click the start button, how long this potentiostat is going to wait before it will actually begin the operation. So if you wanted to immediately respond to the operation, you can set to 0, so as soon as you click the run button, the running is going to start. The sensitivity here is essentially how sensitive this potentiostat will be. And if you set it to a high of a sensitivity, then your scanning range will become lower. It will easily get saturated if you set a very high level of sensitivity. On the other hand, if you set a very low sensitivity, although it is safe from getting saturated, you will probably not get enough of the precisions in your final value. So a good selection of sensitivity is going to be a balance of the precision and then also the scanning range for the curve. So typically in our measurement, we recommend you to select e to the -5 or e to the -4 as the starting point for the scan. Once this is done, click OK. Then parameter settings are all ready. All you need to do is to run a hardware test from the setup menu. You want to see in the pop-up window at this potential offset test, this channel test, sensitivity test, and then the analog circuit test are both indicating OK. If one of these 4 checkpoints says non-OK, not OK, it's not displaying OK, you want to just re-examine the connection of your alligators and then also your parameter settings to avoid any of those errors, and then proceed after you address those errors. This is important because if one of those 4 checkpoints is on OK and then you run this click run button there, then this potentiostat may apply too much of the potential to your cell and then potentially damage your sample. So it is critical to actually run a hardware test before you move forward. So now we're seeing OK, so we can proceed. Click OK and click the run button, and then we will begin the scan. This is the run button. Click the run button and the scan will start. And that's it. That's how we do the cyclic photometry. Okay, now the scan is completed, and I could just save the data. I could just save it. Go to File, select Save As, and then in this pull-down menu, save it as either text or the CSV file in your designated folder, and then you can access those data later on. That's all about the cyclic photometry. We could also take a look at the parameter settings for the chronoamperometry. Again, to switch different technique, we'll go to Setup, Technique, and here we'll choose the chronoamperometry, and then similarly, a pop-up window is going to show up. Over here, we have the same, almost the same set of parameters: the initial potential, the high potential, the low potential, the number of the steps we would like to have. This determines how long the experiment we would like to do. The pulse width is for each of the steps will last for how long of a period. The sample interval, again, this is, we can just leave it as is, just to choose this number here. The quiet time could be set to 0. Sensitivity, similarly, we choose e to the minus of 5 or e to the minus of 4. And the major difference of the chronoamperometry is in the final plot, the x-axis will no longer be the potential, it will be the time, and then y-axis is still going to be this curve. So the data plot is going to be different from the cyclophotometry. So this is going to be the settings for this chronoamperometry. And then if you have any further questions, just contact Acta or myself for further discussion.